Here the main part of the objective is what is the mass of lithium hydroxide needed to absorb carbon dioxide from 1 liter of air containing 30 mm of Hg partial pressure of carbon dioxide at 25 degrees centigrade. Here we need to use the concept of two different chapters. One is related to the stoichiometric calculations and second one the gaseous state. First here, actually what we need to do here is we need to calculate the mass of lithium hydroxide which is required in order to absorb certain quantity of carbon dioxide present in 1 liter of air under these conditions. So what is that certain amount of carbon dioxide present in that 1 liter of air? So in order to calculate that one, based on the data given, we need to use the basic relation PV is equal to nRT, where the pressure is given as 30 mm. So in order to convert that one into atmosphere, it should be divided by 760. So 30 upon 760, and volume is 1 liter. And here we are calculating the number of moles. And as the volume is in liters and the pressure is in atmospheres, R value is 0.0821 liter atmosphere per Kelvin mole. The temperature is 25 plus 273, that is 298. After rearranging, when you solve this, finally you will be getting the number of moles as 0.00164. So now we have this many number of moles of carbon dioxide which is to be absorbed by the lithium hydroxide. Now we need to write down the reaction between the lithium hydroxide and carbon dioxide, and it is like this. Lithium hydroxide absorbs carbon dioxide and that is converted into lithium carbonate, and of course water is also formed, and this becomes 2 moles of lithium hydroxide. So here from the basic equation, 2 moles of lithium hydroxide is combining with 1 mole of carbon dioxide, or 2 into its gram molecular mass, that is 24. 2 into 24 grams of lithium hydroxide absorbs 1 mole of carbon dioxide, and here we are having 0.00164 mole of carbon dioxide, and this much amount of CO2 is absorbed by how much quantity of lithium hydroxide? It is 0.00164 by 1 into 2 into 24. On solving this, we get the final value as equal to 0.07878 grams, and this is nothing but equal to 7.8 into 10 power minus 2 grams, and that is there in option B. Is it clear? Actually what we need to calculate is what is the mass of lithium hydroxide which is required in order to absorb certain quantity of carbon dioxide which is present in 1 liter of air, which is exerting a partial pressure of 30 mm of Hg at a temperature of 25 degrees centigrade. So from this particular data, first we calculated the total number of moles of carbon dioxide present in that 1 liter of air. That comes to this one. Then based on the stoichiometric equation between lithium hydroxide and carbon dioxide, we can find out the mass of lithium hydroxide required in order to absorb this many number of moles of carbon dioxide.